So this is where we are in the schedule. We're going to go just for maybe 20 minutes talking about this, and then we'll get into the practical exercise. And once we start opening up the practical exercise, this is the time to put your hand up if something isn't installed properly, and we'll make sure that everyone has stuff running before we actually start with that. Oop. So I put a link up here. I'm going to do a couple of live demos of different websites. And the links are really, really long and terrible. You wouldn't want to try to type them out. So I put the links also on this website, which is much easier to copy from. So this is basically a website where I type something and it also appears on all of your computers if you go to this website. So if I need to copy and paste something from mine, and then you guys can take it. This is going to have a few links in it. So I'll give you a second if you want to go to this link, and then we'll continue with the lecture. And tell me if that works, if you see some text links there.
Leave it up for a second.
Here.
Can you make it a little bigger?
Yeah, I was just thinking that that's maybe a good idea. Yes, perfect. I see that it's working for people. Even for you guys in the back.
Can I use from this video?
It should be able to. I'm not sure exactly how VS Studio works. From this one, you should be able to run Python, right? Yeah, if pip works, then it should work. Okay, let's continue then and talk a little bit about online processing. So this is also something that has really only started in the last few years. Maybe the most famous one is Google Earth Engine. So if you think about using Google Maps or Google Earth, and Google Earth, you have this spinning globe and you can zoom in and you can see a picture of wherever you go. So the next step from that is giving you access to the data. Rather than just looking at the picture, be able to add two data sets together or multiply or take an average over an area, something like this. And just like if you're going on Google Maps or Google Earth, you don't want to download all this data forever you're looking at, right? Then it becomes gigabytes and gigabytes and fills up your computer. The idea with this online processing is that all the data lives there on their servers, and you just make some simple processing requests, and they only send you the result. So you only are downloading very small bits of data, but you can do quite large analysis. So analysis that would be very, very difficult to do on your own computer. Another nice thing, especially in some place where you don't always have perfect internet access, is that you're not downloading these big things and then something gets canceled and you've lost half a day because you lost your file. You're only working with very small files, so just sending some commands and receiving small data back. They also have many more data sets available than you would ever be able to have on your computer. And you can access them either from programming language. So we work a lot with Python because it's a nice general language that you can do a lot of different things with. But you can also access them on a web browser. So you can also access them without installing anything. So the first example I'm going to quickly go through is the EO browser. So this is from the European Space Agency. And they have basically all of the data sets that are in the Sentinel series, so all of the different satellites that the European Space Agency has launched. And they also have some of the other ones like Landsat, so the ones that are from the USGS. And now this is where I said you probably don't want to try to write this link yourself, right? This is why we look at the SharePad link, which should be here. So if I copy and paste this, it should open up something like this. So this is the EO browser, which maybe I can refresh this and we see how quickly this actually loads. What you can do is that you can go in and you can select many different data sets. You can choose where you want to look, and you can choose how you want to visualize it. So for example, right now I'm looking at Sentinel-2 data, and I'm choosing a date range basically from the last month. And then if I go to visualize and choose one of these data sets, so this is exactly what should open on your link. This is the Sentinel-2 image from February. This is maybe 6 or 7 gigabytes of data that just came up in 2 seconds, right? So if I just want to look around and see what it looks like in general, and see, okay, were there clouds there, something like that, before you decide to do any other analysis, this is really nice. And you can also change how you visualize it. So right now, this is the true color, so just red, green, and blue, so what it actually looks like. But you can also choose different indices. So in remote sensing, we use a lot of different, basically, ratios. So if you want to look at vegetation, you look at the difference between the red and the infrared. If you want to look at urban areas, you might also use blue or one of these other colors, or spectra, so ultraviolet, things like this that you can't actually see with your eyes. And from that, you can get a better idea of how much vegetation there is, how much urban cover there is, how much snow cover, is it water, or is it land? There are many different ratios that we use. And to do all these ratios, you have to do some math, right? You have to take these 2 different bands and divide them, add them up. So you actually have to do quite some processing on them. What this is doing here is doing that all on the fly for you. So if you just want to explore, okay, right now we look at NDVI, which is about vegetation. Maybe we switch and look at NDWI, which is about water content. And if you just want to quickly look at the differences between these things and explore an area without having to download the data yourself, this can be a really nice way to do it. The other thing that you can do quite quickly here, I guess this is slowly loading from my bottom corner here. Yeah, there we go. So now we have this basically this water content ratio that we can quickly visualize here. The other thing that we can do is if we go up here in this corner here, you can choose an area and get some statistics about it. So if you're only interested in, for example, you zoom in on a reservoir and you want to know what the temperature is or what the ratio is of water content. Is it frozen or not? Or go to a forested area here and see how healthy is the vegetation at different times of the year. You can choose an area. So if let's select a little area here over this. And I should be able to, I probably have to log in to do this. So you might, if you want to make a login, you can also access these tools. Otherwise, you can just see how I'm doing it. We can get some statistical information. So this is what this is doing, is it's taking all the data points within this box and giving me a histogram or giving me a time series. So for example, this is now for the last month, all of the different data. And if we go back, let's say for the last 5 years, this is downloading or doing an average over this region for 400 or 500 of these images. So now we're talking about 400 or 500 gigabytes of data that are now just being plotted for us on this chart. I guess it's going to take a second, but it's slowly working its way back here. So if all you're interested in is some statistics or a time series of a very small region, and you don't want to have to download all that data yourself, and all you need is this chart, then this is a perfect way to do it, right? You've just saved yourself a lot of time and internet bandwidth just by creating your own little area here and looking at the time series. Butter, you wanted to add something?
No, I just wanted to emphasize, this is a very new development from the European Space Agency, ESA, but you have the equivalents also from the NASA, the USGS Earth Explorer, that you don't have to download data anymore, that you can do the processing in the cloud. This is really only something that become much more popular in the last couple of years. Specifically now, Sentinel allows you to make a free user account. You don't have to pay for it. A couple of years ago, you still needed to pay for it. Now you can make a free user account at Sentinel Hub and use that Earth observation browser. And I can't stress enough how cool this is compared to,
a few years ago.
When I was still doing research for my PhD, I had to download hundreds of images, right? And now you don't have to do that anymore. Taylor is doing the same. That took me a month or even several months, and you are doing it in
right.
5 minutes now.
I mean, this is hundreds of different images,
Yeah.
right? It's a lot of data that's just being done for you quickly. And if you don't need the whole image, you just need something here, then this is so much faster.
So picking up those skills is very, very important. So again, you can make yourself a user account and explore the Earth observation browser and extract data, and you can download the results then as a CSV, right?
Yeah, you can just download the data points if you want to plot them yourself or do something else with them. You have access to it from here. So when you're in there, there's other things in here. I don't have time to go through all of the different possibilities. The idea is just to give you an idea of what is possible with some of these online tools now.
So I see some of you are doing you're creating an account, right? So let's wait a couple of minutes. Let's see how that.
Well, we can come back to this. I can talk now about Earth Engine, and then we.
It's still running, okay.
Yeah. Let's look at a couple more examples, and then we can keep coming back to these things. And if you have questions, then we can keep returning. So that is one platform, the one that's from the European Space Agency. Then there's also the Google Earth Engine. So this is one clearly from Google, right? It's just the extension of Google Earth. And they launched this at one of the COPs, so almost 14 years ago. But it's only really become a really big thing in the last 5 years. They had a sort of a demo phase, and then it's gotten bigger. The main thing is that if you're not using it for commercial purposes, it's free. So if you're doing education or research or also working for an NGO, something like this, you can use as much of this as you want. And I think this year they also launched for commercial things. I have no idea what the prices are, but I think a lot of you guys are in the academic or research or NGO sector, so working with this data is quite a nice thing to do. The big thing with them is that they're based on these Google servers, right? Google is always one of the fastest websites that you load. They have quite a lot of infrastructure, and so they can host a lot of different data, way more than we could ever imagine using. And they also get the data very quickly. So they have agreements with all of the different satellite providers, so with the ESA, with NASA, so they get the data very, very quickly, usually within a few hours. So if you're looking at something for a rapid assessment, this is also an option. Once I go into the exercise, I'll go a little bit more into the catalog. But just as an example, they have every single Landsat scene that they took from the USGS. So that's, petabytes of we're past giga, past terabytes, and into the next one, the petabyte scale. So they have really a lot of data available. And it's been used for quite a lot of different purposes. This is maybe the next link on my share pad here, which is, or I think it got cut and pasted out of there, so I put it back in. So we're all sharing this thing, so if you delete something, it gets deleted for everyone. What this app is, so someone decided to do an analysis of how global forest cover has changed. So they use Landsat data to look for areas that have changed from being forest to no longer being forest. And this is all then hosted as a Google app, so anyone can go in and go see the results of this. And you can use it just like you use Google Maps, right? You can move around, you can zoom in, and what you're displaying is something that's calculated sort of on the fly. Or I zoomed in too far here, I guess. I'm in an ocean. And you can see at quite high scale or high resolution, and it loads very, very fast. This is huge amounts of data that they've processed, and now it's just hosted for them by Google for this research purpose of looking at global forest change. And this is one example. I'm going to show a couple more as well here. Just to give you an idea of the kind of scale of the analysis that you can do. Let's see. So the next thing, I'm going to actually do a couple quick live demos with the Earth Engine online tool, and then for the practical exercise, we're going to actually work with the Jupyter notebooks, which let us access it via a programming language rather than just on the web interface. So let's look at this next link. So we're going to look first at this Landsat data. So I'm opening up wrong link. First I want to open up this. Yeah, this catalog. Somebody else is copying it at the same time. So this is just a link to the data catalog. So every data set that they have on Google Earth Engine has a whole description about it, and it tells you something about, for example, this Landsat level 9. This is just from the last few years. This is the newest Landsat that they put up, and it gives you a big description about how the data was collected and where it's from. It tells you all of the different bands, so everything that you would need to know if you wanted to do some analysis with the satellite data. And it will also always give you a small piece of code on the bottom, which you can either access in JavaScript, which is the language that they use for the web interface, or you can also access it in Python, which is the syntax that we're going to be using. And I think you can even launch this directly into Google Colab, which is another one of these Google platforms which lets you run some basic codes on their servers. So if you take this code and open it up in the Google Code Engine, so this is now the next link that I'm talking about here, this one, this should open up directly into let's reset this. This is the basic interface for Google Earth Engine. Which gives you a little window where you can type your commands. It tells you something about what you're running, and it gives you a sort of a base map where all the analysis will show up. So this, I'm not going to go too deeply into what we're really doing here. All I'm doing is I'm using this exact same piece of code. The only difference is I centered it on Kathmandu instead of wherever they centered it, somewhere in California. So all it's doing is it's going to load the whole set of all of the Landsat images and just select one and visualize it. So nothing too complicated. And if we run this, it should run pretty quickly. So if I hit it, I can tell if it's running or not. And there, within just a couple seconds here, I can select, my image from the beginning of February, loaded up, and it's just like working in Google Maps now, right? So I can zoom in, it'll load in pretty fast. I can say, okay, I want to zoom in to Kathmandu. I think I even centered this somewhere over the hotel. But this is this is a huge data set that is just quickly available to look around in, right? It's like the next level of going into Google Earth. You have to do a little bit of extra legwork because you have to choose what date you want to work on, but otherwise this is exactly the code that was already on their website, just copy and paste it in. So if you want to look at a different date, we can just choose a different one, and it will pull up a different image. Maybe let's try that. Let's go from sometime in December instead. So I'm just changing the date here, and that will give me a different image. And if I run this, it will zoom me back out to Kathmandu, and hopefully in a second it will then load up a different image from December. Oh, where we have a little bit more snow up here, huh? Not so much anymore. So that is one nice quick example for just opening up and visualizing some data. And the last demo I wanted to give here is actually doing a little bit of basic analysis. So this is, I'm going to close these ones. And if I go to the last two links here, oh, I got to copy them in again. No worries. I'm going to look at some fire data. So I'm going to copy them here at the bottom. So this is just another data set that's available on Google Earth Engine, which is from the MODIS satellite. So MODIS is a satellite that's been up since 2000, and it covers the whole globe basically every day. And they have this burned area monthly composite. So it goes around and it tracks if there was a fire, and it maps out how much area has been burned. And this is data that's then available every month. And again, of course, on the data set, we have a little bit of code if we just want to open it up and look at it. But I'm going to go one step further and do a very basic analysis. So let's copy this one in. Which what I want to do, this I think it's just going to automatically run as soon as you open the link. What I'm going to do here is I'm going to select all of the data for the last 20 years. And then I have a very simple function that just counts if it burned every year and adds them up. So if it burned in 2001, 2002, if it burned every year, I add them up, I have a value of 23. If it only burned once, I have a value of 1. And as you can see, that took, like 3 seconds for this to run for the entire world. And I can zoom in anywhere I want here, right? And it should quickly load this data set. So if I zoom in somewhere in Central Africa here, obviously there's quite a lot more fires there than there are in some other parts of the world. But this very simple code, just checking if there was a fire every year and adding them up, this is running over the entire globe in a matter of seconds, right? And that is a lot of data to have to come in and process and do something to, and then add it all up and get a result, and then visualize it. So this is basically, I like this example because it emphasizes how much you can actually do with just a short, it's only 30 lines of code, right? And even less because there's a lot of empty lines in there to do quite a powerful analysis. And maybe the last thing before we go away from this example here is to talk about this little corner, which whenever you have something printing out data, if you want to count the number of images and tell yourself how many there are, you can print things out. You also have something up here called the inspector, which if you turn this on, you can click anywhere and it will tell you what value you have there. So if you want to know for a very specific place, this is a sum of 11, so it burned 11 times. And if I go down here in this brighter stuff, I have 21, so this burned 21 times over the last years. So this is then, again, going for specific locations, and if you're only interested in there, you can still get that value of your calculation out directly. The last one is tasks. So if you wanted to export this map, so you could open it in QGIS or download it or save it somewhere else, you can also just export this data to your Google Drive and have it as a file that you can use anywhere else. And this we're going to talk a little bit more about in this exercise. I'll show you guys how to export some data and how to work with it offline. So, Bodo?
Just a quick question. So is everyone comfortable with navigating around in Google Earth Engine, what Taylor just has been explaining and showing? I think that well, it's not only a great tool to know about, but we will also use this throughout this workshop. So is everybody able to log in and access those examples that Taylor was showing? You know, now would be the time to let us know if there's a problem and we try to resolve this.
Yes, there are also problems.
So, this is basically what a Jupyter Notebook looks like. It allows you to put both text and code. In here I also have a bunch of different links. So there's data about the different data sets that are available. So if you want to look at all the different things that are available on Google Earth Engine, here is where this is. There's also more just general information about Google Earth Engine there. The idea of what we want to do in this short first exercise is basically access a bunch of climate data for one single point location. So like when I showed this example and we just clicked one point and said, this is how many fires are exactly there. What I want is to get a time series. So more like the first data that I pulled from the EO browser, where I have this time series of how things are going. But I want to just choose it for one point and make a nice little chart about this data and potentially save this data if you want to use it for something else. And for those of you who are not so familiar with Python, I saw some of you looking up things about how this works. This is basically the easiest way to use Python. This is just running a couple commands at a time. But if you want to dig in more, there's a lot of different instructions about how to do all sorts of different tasks for data analysis and data management with Python and Google Earth Engine. So the basics of how Python will work when you're running a program is that there are some functions that are always there, and then there are ways to add new functions. So there's not always a function to make a chart, for example. So this is why we're going to add some of these extra modules that I saw you guys all downloading and installing. These are these extra modules that we need. So this PyPlot one allows you to make charts. The NumPy allows you to do numerical operations, so a lot of different math. And then there's also one that does dates and times. So if we want to make an analysis about only data in March and only data in December, we need to know what time the data came from, right? What day it came from. So this helps us manage everything that has a time associated with it. To run something, all you do is hit Control-Enter, or you can hit this Run button, and that will run this cell. So once this little number comes up here, that means that it ran. So this has been successful, and you now have access to all of these different modules. The second command here is how we're going to access Google Earth Engine. So Google gives us this little library of functions that allows us to access all of their data and run processes, do addition and trends and all sorts of different things. And we use this Earth Engine module. If you're doing this for the first time, you have to log in. So you can use this EE Authenticate. So just delete this. When it's no longer this sort of slanted text, the blue text here is going to be ignored. So if you delete this and run this, it will ask you just to ensure that, yes, I am using my Google account to access Earth Engine. So it should give you a little pin that pops up, and it will just say log into your Google account. And once you do that once, it will always remember your computer. So you only have to do this once. After that, you can just run it like this. And if you have something come up here at the bottom, I have it printing out a little version so I know that this ran. If you don't have any errors, you're good. That means you have access to all of their data and the commands. Going on from the second piece here, once we have the Earth Engine installed and linked, which I think most of you have done, we can now access any of the data. So what we're doing here, this is basically my little test to make sure that everything runs. We choose a data set, so in this case the elevation data. We choose a location, so in this case I chose Mount Everest, and then I just sample this location. So all I'm doing is just getting the elevation at one specific location. So this is sort of a test for what we want to do after, which is get the value at many different times at a certain location. And this should run only in a couple of seconds. It accesses this really big data, chooses a location, and just gives you the value. So this is basically what we want to do, except over many different images all at the same time. So the main thing here is that we're not actually processing anything on our computer, and we're only downloading one little value, right? We're basically accessing 500 gigabytes of elevation data and only getting one value out of it. So we're saving ourselves a lot of work on that end. And we can do this for anywhere we want. So for this first exercise, I chose right here. I chose the GPS location of the hotel. But you can, if you want to, while we do this exercise, choose any other location you like. So if you have a weather station that you know, or a hydropower project, or your house, or your friend's house, anything you want. So the way I found this location is I just went into Google Maps and I just right-click. So you can go anywhere on Google Maps and right-click, and it will give you the latitude and longitude. And this is all the information that Google Earth Engine needs to be able to start accessing the data. So you can go on Google Maps or on Google Earth, or you can get the GPS from or the data from a GPS if you have it somewhere, anything you want. So I'm just copying and pasting this. And then I can define a geometry. So to make a geometry to tell Earth Engine that I'm looking at one specific point, I just have to add these two numbers that I copied and pasted straight out of Google Maps. So I make my geometry, which I'm calling the hotel, and then I'm using this same elevation data set, and I'm doing a sample at the hotel, and I'm printing out my elevation. So this should print out our elevation right here at the hotel, which should take a second and say that we're at 1,312 meters. Does this make sense? Good, I see some people nodding. So let's then continue to the second piece. So now that we know how to choose a point, what we want to do next is we want to choose a data set. So of course, maybe it's interesting to find out what the elevation of your house is, or find out the elevation of your parents' house is. But what we're really interested in here is some more climate data or environmental data, right? So the first step that we do is we choose the location, and then we choose the data. So like I said before, if we look at the data catalog from Google Earth Engine, it's really, really big. There's lots of climate data. So for example, they put up the surface temperature, climate data. There's atmospheric and weather data. So now there's data about aerosols and dust content, even carbon dioxide and methane. There's also these different imagery. So this is what we looked at first from the EO browser, the Sentinel data. There's also the Landsat data, which starts all the way back in the 70s. So we have quite a lot of data that we can choose to access here. And the nice thing about Google Earth Engine is that it's really easy to access a data set. So for example, for this first test, I'm going to choose some precipitation data. So there's a data set called CHIRPS, which is developed at the University of Santa Barbara in California. And they use both satellite data and some climate station data to make a really nice, well-calibrated rainfall data set. And so I can look, again, like we did this morning, at any of these different, all the attributes of this data set. We have some description, and we have an idea of what's in here. The only data that we have in here is precipitation, and it says a rate, so millimeters per day. And we can also then see the resolution. So this is about 5-kilometer resolution. So not the highest resolution, but still pretty good for rainfall. And it covers the whole globe from 1981 until the end of January. So they're about 2 weeks behind live. So they are doing their processing continuously, and Google gets it about 2 weeks after it happens. So if we want to access it, all we have to do is add it as an image collection. And this is exactly the line of code that is here in the description. Every dataset description has, maybe I zoom in this a little bit too, has right here, Earth Engine snippet. This is the name of the dataset if you want to access it via your Jupyter Notebook or via Python code. And with this name, you access the whole data set. So now I have my rainfall data set, and as a first thing, I'm going to check the size, so how many days I have in here. And this get info says actually run the command. So if I run this, I get that I have 15,736 data points. So I have a lot of different data points accessible here. If I don't use this get info, so if I add a little hashtag here, that means when this code becomes blue, it's not going to be run. That's saying like ignore all this stuff. If I just run like this is what I'm actually sending to Google Earth Engine. So I can prepare these commands and not actually have them run and not actually download the data directly. So this is basically what I'm saying. Hey Google, I'm interested in the size of this particular data set. What you should do is all these commands. To actually run them, I use this get info, and now it will give me the length of my data set. So we have then, just by opening this data set, access to a lot of data, which is maybe too much data. We don't need to download 15,000 data points to make our simple chart. We can also do some simple filters. So for example, this is the same code here, I just added a date filter. So now I'm only looking for data from the beginning of 2023 until like 2 weeks from now. So up until the latest data that they have. And then I can again check the size and see how much data that is. Now it's closer to 400 days of data, which is a little bit more reasonable to download and make some first charts out of. If you really want the whole length of the data set, of course you can still access it. But for our demonstration, we'll just make it shorter so everything runs a little bit faster. So the next thing is, maybe we don't have to explain every single little piece that goes into this code. For those of you who are not super familiar with Python, what we want to do is get the date of every image, sample that data, so at each specific point, and then give me back a date and a rainfall value. So you don't have to understand everything that is happening in this little function to understand what's going to come out of it, right? If you want to become Python experts and dive more into this, then you can spend some more time learning exactly what all of these different lines do. But for now, just to demonstrate what's possible, we're taking our rainfall data set, we're creating the time series, and then we're downloading the time series. So now this time series variable will have all of the dates and all of the values over the hotel. And you can see that took, what, like less than a second? And we have now, it's going to take longer to print it. We have this really long, ugly data set. This is basically a big list of dates and values. So we have all these values. We have our 400 data set, or 400 data points. And that took 1 second, right? So if you want to choose a location and just quickly get a time series, great. Of course, this format is really terrible. You wouldn't want to try to use this to make a chart directly. So we have to do a little bit of data cleaning. So all we're really interested in is this date and this value, right? So that's what this next little piece of code does. It uses a Python loop. So in Python and in most programming languages, you can take a list of values and go through them one at a time. So do something to the first thing in the list. Do something to the second thing in the list. Do something to the third thing in the list. So this is going to go through all our features and get out the date and the rainfall and print them. So that's all that we want to have out of this, right? We go through, we know that we have a lot of data in there. And if we just print this, we now get something that looks a little bit closer to what we actually want to work with, right? So rather than this really nasty, large piece of data that we get out of Earth Engine, we can quickly reformat it into something that looks like this. And here we have a lot of zeros, of course, because it doesn't rain every day. And then we have some values for our rainfall rates. To actually now then make those into something that we can use to make a chart, we have to save them somehow, right? We have to store the dates and we have to store those values. So I add a couple extra lines on here, which is just making an empty list. So just make an empty place to store my data. And then in the same way, get my date and get my rainfall, and then add these things to the list. This little extra piece here, as I explained, converts this date. So your computer doesn't know what this means, right? Like we know what this means if we look at it, but a computer doesn't know if this string, if this set of characters is before or after this one. So what this does is it turns it into something that the computer can understand. And that's just what this datetime module does. It's really good at converting these kind of unstructured or regularly structured data sets or dates that we get and turning them into something useful. So again, if we run this, it goes quite quickly. And if I look at this, rainfalls. Now it's a list with just the values. And if I look at dates, it's the same thing. Dates is a list with these organized date times. So this is something that Python understands, that this one comes first, this one comes second, this one's in January, this one's in March, etc. To add this extra little thing in there, I just use this plus. This adds a new cell. So if you want to type in something extra or change something, you can always add new cells to your notebook. And once we have this, we can use this plotting tool. So this is, again, one of these modules that we added in, which lets us take our dates as our x value and our rainfall as our y value. And then I just put some labels on the chart. So my x label is going to be date, since that's my x values, and my y label is precipitation. And I have now, for the last couple of years, a rainfall chart for right over our hotel. And finding all this data and downloading it and making a chart out of it from somewhere else can be quite difficult. But if you wanted to do the same chart for a different location or a different year, it's the same code. You just change the location or change the date range, and you can make the same chart very quickly. And if I compare this, so I have now my rainfall data for over the hotel, I was trying to find what the closest weather station, the closest climate station to us that actually had rainfall data. And there is one in Kathmandu, but I unfortunately could not get the raw data. So I instead looked at the Department of Hydromet website, which has the station data plotted already for us. I guess it's going to load in a second. This is what my screenshot looked like for the last couple of years, right? So this is going from now until the beginning of January 2023. So the exact same time that we already made our chart from. And if I look at what my highest rainfall value is, it's somewhere in July, and it's about 75. And if I look at my own chart here, the highest value is pretty close, right? I have a July value. So let's zoom out a little bit here. So I'm talking about July, and their station measured 75, and mine is maybe a little bit closer to 80. Of course, their station is not exactly located on this hotel, right? And the climate data that we're using from Google Earth Engine also covers a 5 by 5 kilometer area, so it's an average. So they're pretty close, but they're never going to be exactly the same. But they agree pretty well, right? We can even look at this more closely. Since we have all this data, I can look at what is the maximum rainfall in my data set. I can also look for what is the date of that maximum rainfall, and I can plot that on my chart. And this tells me that this highest precipitation value that I had was in September. So 2023, 9/13. So I don't know, there must have been a very rainy day above the hotel here sometime in September. If we want to go the other direction and look at what the rainfall is on July 17th, so again, that's that time here, July 17th, where I have the maximum rainfall, which is 75.2. What I measure from my rainfall data here is 73.03. So basically the same thing, right? So this is really nice because we don't have to only rely on where we have a climate station, right? If you have some location that you're interested in, you can just add it in, go to Google Maps and choose that latitude and longitude and put it in this same code that you can download and keep using and make a chart, and you have your rainfall rate. Or look for what your maximum is, or choose any date here, right? I just chose a date of July 17th because that's my maximum, and I got the rainfall at that date. You can, of course, also look in your data itself, right? We have this long list here that tells us we could go, okay, 2017, 17th, there it is. We could also go in and find it manually. But there are also, of course, ways in Python to do some of this for us, to have it done via the computer program rather than having to look through this long list. The second half of this first exercise, now that we've made some nice little rainfall charts, I want to make a chart that also has data from a few different instruments all at the same time, right? And a lot of times you want something about vegetation, something about temperature, and rainfall all at once. So this is also something that is pretty easy to do from Earth Engine. We have this huge data catalog, right? So any of these different data sets we can load in, and we can load in lots and lots of them all at the same time and access them in a very simple way. So I'm changing my point. Of course, you can keep using your house or your project or whatever other point you want. I chose a point up near Langtang, which is a little bit further up into the Trishuli. But otherwise, this is the same code. I just changed the name here to be Langtang, and it has a different GPS location. And this is at 3,500 meters. So I'm going to keep using this same rainfall data, except I'm going to go a little further back, so from 2022. And I'm also going to get temperature and vegetation cover. And so both of those are data sets that are available from MODIS. And MODIS, you get data usually 2 times a day for some, well, 2 times a day for some data sets, and more like once a day or once every 8 days for other data sets. So for temperature, we have this daytime temperature, which is at 1 kilometer. And this we get every single day. This is really nice. Vegetation cover, we have NDVI, which some of you have probably heard of and some of you have not. This stands for the Normalized Difference Vegetation Index. And it basically is how green are the plants. How much chlorophyll are the plants producing? So this is a really common way that you measure the health of crops or trees or something else like this. And I'm using the same date here. So I want the data also from the last 2 years. So I'm always just copying and pasting these pieces, right? You don't have to do them again and again. Once you've written this up or once you take this home and want to change it, you can just copy and paste things into a new configuration. So running this cell, now I have these 3 variables. And I made a slight change to my time series function here. So instead of just going through one data set every time, I can say which data set I want. So I give it in the rainfall, or I give it in the temperature. And then I say which variable I want out of it, and I somehow give it a name. So when I get my long list of values, I know what my data is named. So this way I just took this same function from before and added a little bit so it's more flexible, so I can analyze 3 different data sets using the same function. So when I run this, it should take a second, but now I'll have a rainfall series, I'll have a temperature series, and I'll have a vegetation series. And that that ran pretty fast. So if I look at these things, I can look at veg series, for example. And it's, again, this really long thing. But I have, instead of rainfall, I now have a date and I have some vegetation cover. And that's exactly what I named it right here. So that name is this name. Now for temperature, I can do the same thing. If I look at my temperature series, it should be this same kind of format, but with temperature. Here you might notice this temperature is not a really a real value for temperature, right? That's not 1400 something degrees. That's not a real temperature unit. So a lot of times when you get satellite data, to make the file smaller and to make it easier to share and download, you store it as a smaller data type. So you store it as these integer values instead of 0.7 or something like that, just because it's much more expensive for a computer to work with and to store anything that has a decimal place. So we have to convert these. We have to turn them into a different value. And the way we do that is we can look at any of these data sets. So let's do a quick Google search here and open this data set. And this will tell us that if I look at what bands are available and I'm looking at my temperature, the units are in Kelvin and I have a scale value. So if I want to convert my 1400 whatever degrees to something useful, I just have to multiply it by this scale. So this is something that you see pretty commonly in data, and it's already in the code. You don't have to go in and add this scale yourself, just as something to be aware of. If you start doing this with other data sets and you get some values that are really weird, you should go back and look at the data description and see if there's some sort of scale value in there. So now I have my 3 time series, and I just want to do the same thing we did before, right? Looking at these features and getting the date. and turning it into a date. So I just, again, made this a slightly more general function so I can give it my rainfall series and the name of my rainfall variable. And it will turn this into my dates and my rain values. So the same thing we did above, I just made it more flexible. And now if I look at one of these things, I can look at veg, for example, and it just has the values. And it can look at the veg dates, so V dates, and it will just have those dates. And they should be different for these three things because I've given in to the function three different variables. And now, just like we did before, I can make a plot. I'm making a slightly fancier plot since I'm putting three different things on it. So this is just a little bit of extra code to make the figure a certain size, to change the colors, and to give them all different labels. And you can see here is where I'm doing my conversion. So for temperature, I'm using that 0.02 that I found on the website, and I'm changing it from Kelvin to Celsius with this conversion factor. Now NDVI, the conversion factor is even smaller. So again, I found this on the data description, and I just multiply it by that conversion factor. And that should now give me, let's zoom out a little bit so we can look at all three. This now, for that point, I have my rainfall, my temperature, and my vegetation. And they match up pretty well, right? It rains in the hotter part of the year, and that's also when the vegetation is growing, right? And then we have less vegetation sort of towards the winter when there's less water. It all makes sense, right? So this is quite flexible, right? You can choose any sort of data set that you want for this kind of analysis. Modis has, I think, 30 or 40 different products that you could use. So even from just that one instrument, there are a lot of different options. Yeah, maybe let's look at also this. I put this in last night as the special bonus since somebody asked about how you might actually download this data, right? You don't just want to make a plot, but you might want to have it and look at it in Excel or something like that. And in my opinion, and the easiest way to work with this kind of time series data is to use one more module, and we're going to use this also a lot tomorrow and later in today, which is called pandas, which is very good for working with time series data. So anything that you would open as like a spreadsheet, pandas is the way to go. It's really good for this kind of data that has rows and columns, so labels and different variables. So all I'm doing, for example, for rainfall, is I'm making a data frame that will now know that all my dates are called date and all my rainfall is called rainfall. And it should not take any time. But now I have this nice structured thing here, right? So I have a column of dates and a column of rainfall values. And this is, again, you can use it in the same way to make the same kind of plot. It's got a slightly fancier default bottom, right? So I'm using the pandas plotting instead of the basic Python plotting, but it's the same data. But the last and most important thing here is that you can just directly export to some sort of structured file. And we usually use CSV, which is this comma separated value. So it's just a value and then a comma, and then a value and then a comma. And this is a format that's commonly recognized. You can open it in Excel, you can open it in all sorts of different programs. And so all we need to do is give it a name for the file, and it will write to that file. So if I go in here, I should, in my time series folder, have this Kathmandu rainfall. And if I open it just as a CSV, it just looks like this, right? It's just a bunch of values with some commas. And I can also open the same thing in Excel, of course. Excel always takes a second longer to open, but it's here. So if you're more comfortable with making your charts in Excel, for example, or you have some other analysis that is already linked to Excel models, then this is an easy way to export it and then link it to your normal work that you're doing. And it's just this 1 or 2 lines, right? I just used 1 line to make it into this pandas format and 1 line to export it, and then I have the data. Cool. So that is the end of this first exercise. Do you guys have questions at this point, or do we want to move into the second one?